Okay, so let me first explain what I mean by surprises. So it's kind of thing that you get used to it, for example, in Java, and you suddenly come to Kotlin because your team decided to do so, and you find some things unnatural. So I try to summarize such stuff, and my intent is not to advertise Kotlin too much. Of course, I like Kotlin, so it will be hard for me, but I meant to show these places where it's generally surprising. So in some cases, it will be even a bit negative for Kotlin. I will try my best to explain it to you why the Kotlin the designers did so, and we will try to understand it together. Okay. So we'll start with syntax supporting internal DSLs. I bet it looks a bit scary, so let me first explain it to you. For those of you who don't know what DSLs are. So imagine an SQL. It's just a simple language which is designed to do a certain narrow task in a good way. It's not a general purpose language like Java or, for example, JavaScript or C++. And internal DSLs are certain kinds of APIs in general purpose languages which are designed to accomplish a given task. So I can imagine an internal DSL in Java which handles some SQL queries, like Hibernate, I guess, has one. And in Kotlin, there's this notion of, for example, type-safe builders, which are internal DSLs, which express a certain structure. So let's see how Kotlin enables us to do so in a readable way, comparing to Java. So let's start with this simple code in Java. It looks a bit old, right? So here we use here we have a single call to some function, which as the second argument takes another function. In Java before 8, excuse me, we had to use an anonymous class, so it looked a bit verbose. And I bet if you see this code, you rather understand it like a function which accepts some callback. For example, if you make some web network call and something has to happen after it's complete. So in case of DSLs, the goal is a bit different. It's rather about describing a certain structure, like in, for example, JSON. So think of it about some function which is like a parent object, and then another function which describes some child object. Now let's see what Java 8 gives us. Well, we have lambdas, so it got a bit shorter. But still, let's see what Kotlin has to give us. So translating directly the code from Java to Kotlin, it looks like this. And we immediately see this hint from IDE that we can move out the last argument out of parentheses, because in Kotlin, if the last argument is a lambda, we can sort of simplify it. So let's do it. It looks like this. And another opportunity to simplify it is if the lambda accepts only a single argument, it can be used as an implicit argument called it. So it looks like this. I realize that this example may not be may not show some real life case, but I hope that you see where Kotlin tries to cut off on the boilerplate and make it more readable. Next topic is related to null safety, so this billion-dollar mistake and so on. There are multiple approaches to this. Let's see what Kotlin has to give us. But first, let's see Java. So in Java, in each project and team, you have to decide which approach to nulls you want to take. There are different libraries like Lombok, simple annotations. Let's go through them shortly. So the simplest approach is to use, for example, primitive and reference types, like like in case of integers. If some value is not nullable, then use int. If it is nullable, then use integer. But what if we have, for example, a string which doesn't have a corresponding simple type? Some idea is to use optional. Then you have this warning from IDE. Okay, that's cool. But well, it's still just a warning, right? We would have to. We would want something more. And trying the optional on the parameters gives us a warning that it's actually not recommended because of some serialization issues. So, like, I guess there's no perfect way, and the optional way is like a dead end in some cases. Okay, so let's try to use these annotations. I'm starting with some fresh Java project and wanted to use this nullable and non-null annotations. I just started writing these, but it says internal. It's like I'm not supposed to use something internal, right? So Java gives us some annotations, but it doesn't give them. Like, what's the case here? It turns out that they are available as a separate libraries. It appeared as a JSR 305, like in 2006, like a design idea. And as far as I'm concerned, it was implemented by several companies as separate libraries. So the one from Findbugs seems to be quite popular. Let's try to see how it works. Yeah, you have a warning in IDE. Yeah. But I would like to have some at least runtime like exception, but because the warnings are pretty simply ignored in some cases. So let's try Lombok. Yay. I have the warning as well, but also the runtime exception. It works for the arguments, but doesn't work for return values. So what if I wanted to have something compile time, just to, you know, make it even safer and bring this issue to the even earlier stage of development? I learned about this tool called null-away from Uber. I tried my best to configure it within some reasonable time, but I failed. But I believe that it works once it's configured. So yeah, it gives us some compile time errors, and actually that's pretty nice. But now let's see what Kotlin has to offer. So it just works, and null safety is built into the language. In this case, just we have a compile time error, and it's not like a soft warning; it's just an error. By default, each variable, parameter, or return value is not non-null, just to make it safe. And if you want to make it nullable, just specify the question mark at the end, as you see here in the return type. And you also notice that I removed one of the parameters from the function, because previously we had primitive and reference type. In Kotlin, there are no distinctions between the two. The Kotlin compiler tries to infer itself whether a primitive type is enough or a reference type is needed, for example, for the generics. So it also makes it simpler for us to use them. And Kotlin also tries to be compatible with existing Java ecosystem, and this is I guess even incomplete list of annotations that Kotlin compiler supports and tries to infer the nullability information from the existing Java code. So this is a piece of code from the compiler. At the below, you have some link to the compiler code. And I hope like you understand that Kotlin tries its best to work with Java, not just, you know, to cut off from it and work on itself. Okay, now we have something pretty confusing also for myself. If I come back to Java, I tend to confuse the order. So the problem is that this is a simple function in Java. We have first the type and then the name in case of arguments, and in case of return type, we have first the return type and then the rest of the signature. In Kotlin, it's the opposite. You may ask why. It's not to make our life complicated. It's to actually make it easier. One of the reasons is that Kotlin tries to move the focus of the reader to the names of the parameters. So the types are sort of less important because, for example, if you have several string parameters, the information that these are strings is sort of less important than the fact what's contained in the strings. So you see that the variables, the parameters on the right side sort of align to the same column, and it's pretty convenient to read. Another idea, like the reason, is type inference. So in Java, we have to specify the type of basically everything. There are some newer features like var or val in the newest Javas, or in Lombok, which try to introduce this type inference. So in Java, we have like standard definition of a variable, and in Kotlin, to be exact, we could write this, but this instant type in case of defining the value is not needed. You can omit this like this. And the compiler will try its best to infer the type. It's not a dynamic variable like in, for example, JavaScript. It's just hidden from us. We can surface it if you want. It's not like every time without this type. We just, you know, infer it. In some cases, it's really beneficial. You see the double bang at the end. It's needed because in the first line, we specified explicitly that it's instant, which means it's not nullable. But since when we call Java from Kotlin, and Kotlin does not find an annotation about the nulls, it says, I don't know if it's nullable or not. So we have to be explicit and say it's for sure not null. So we write this double bang. Now something about processing of collections. So let's see this simple code. Just a simple list of strings, and we calculate their lengths like separately. You can, so we need this stream here, unless we want to use some loop, payload loop. In Kotlin, to translate it like one-to-one, it would look like this. So you still can use your streams, favorite streams, but what if you didn't have to use them? This is, here you have this map function, which is an extension function. So this is an important feature of Kotlin, which means that it looks like if you extended an existing type, but it's not true. It's just a syntactic sugar. But the benefit is that in the use, like in the place where it's used, it looks really natural. Under the hood, it's just a static method. So in Java, you would just call map, open the parentheses, put the collection, and then do whatever you want with this. But this notation is really simple and clean. So unless you don't have that much items, it's really beneficial to just use this short notation. Of course, in Kotlin, instead of strings, we tend to use sequences. Why? It's not because the JetBrains team had too much time to implement Kotlin. One of the purposes is that Kotlin is intended to be compiled for not only JVM. like JavaScript, native, WebAssembly, and even more. So a sequence is like Kotlin's counterpart for streams that can be compiled to different platforms. So if you really want to use streams, you can do it, but there's also like alternative way. And you may ask when to use streams or sequences and when to use these extension functions. Well, the rule of thumb is that if you have little items in some collection and you are sure it will stay low, you are safe to use these extension functions. And also there's an important difference. Let's, for example, see this code. So the extension functions are terminal. It means that once you call the filter function here, the results of the map call from the previous line has to be computed like all together. And in case of lazy stuff like strings or sequences, this chain here, for example, is just a description what needs to happen once you call this toList at the end. So it's also an argument that in case of large collections, it's maybe beneficial to use the lazy entities or just even plain loops if you really care about the performance. Yeah, no check exceptions. So check exceptions are useful to ensure that the caller handles all the exceptional cases that the library author wanted. So no check exceptions may seem like a regression comparing to Java, right? Well, Kotlin folks thought that check exceptions bring more harm than good. So in theory, it all looks good, it's safe and so on, but for some simple cases, even like this, like logging, or for example, when you want to call some function from a Lambda in Java, well, we have to write this boilerplate. So if you want to know like a full rationale behind this, feel free to head to the docs of Kotlin. But you may ask what we have in return, because Kotlin like wouldn't be like less safe than Java. It would be a bit weird at least. So let's consider this code. We just parse some number, and if we fail, we just throw an exception. The functional approach is that we would encode the exceptional case in the return type of this method. So we can use, for example, either from arrow library to say that if we succeed, it's an int, the return is an int, and if we fail, it's what's on the left side. For those of you who don't know the either primitive, it's just a convention to have the left side and the right side, and the right side is by convention the success path, and the left side is the failure path. And in Kotlin, there are also sealed hierarchies, like also will come in to Java in the newest version, which means that you can have some base class and, for example, 3 deriving classes, and you can ensure that no one else will add more child classes, which actually is as safe as check exceptions, right? So sort of Kotlin goes this functional approach, and it actually plays pretty well. You just have to get used to this, but once done, it's really nice. There's actually a whole talk about this, and it deserves a whole talk. Feel free to go ahead later and check it out. Library functions have their Kotlin versions. So I already mentioned the sequences stuff, that it was made to make Kotlin more multi-platform. But let me show you another example. So let's say we have the simple max function, and the IDE should suggest you that, hey, please don't use the max from Java Lang. Try to use the one from Kotlin. The benefit is that, yeah, as I said, you may one day want to use your Kotlin logic not only for JVM. So it's generally recommended to use the Kotlin counterparts if you only can, because you will have less migration work if you decide to, for example, use JS target. In the simplest cases, these just are proxies to the Java functions, so don't expect any performance penalty. In some cases, for example, for manipulation of with date and time, there are separate Kotlin libraries. This one is actually published by the Kotlin team. So yeah, it may happen that you might need some extra dependency. Also, in some pretty basic stuff like file operations, there are no counterparts in Kotlin. But yeah, as I said, you don't have to worry about this as long as you stay with JVM. So this is just a note for those of you who are interested in using more platforms. Top level functions and constants. If you ever used Python, you saw it probably, but for Java, this is pretty surprising. So let me show you some examples. So yeah, Java, we have a some top level class, and we can have only one, and the name of the file has to match the class name. In Kotlin, it's not the case. You can have as many classes as you want, the same for functions and variables, values, and the file name can be anything. So at the beginning, my impression was that, okay, now it's going to be mess in all the files because we are going to put everything in no order. But this freedom actually is good because if you look at this from the other side, Java forces us to create separate files for simple entities, and it's also hard to read. Of course, you can put inner classes in Java to achieve this, like some utilities, but this freedom, I actually like it from my experience. And if you really don't like this kind of freedom, you can use a linter. So this KT-lint, it's like an industry standard linter for Kotlin. There's a rule that ensures that the file name matches the class name. But yeah, it's sort of the approach opt out, not opt in. No ternary operator. So we got used to this in Java. Why they removed it in Kotlin? Example in Java. In Kotlin, it would look like this. So you can see this if construct. You can immediately see that it's sort of like if returns some value itself. So in Java, if is a statement. So it doesn't return the value, but in Kotlin, it does. I guess Kotlin designers thought that if the ternary operator can be replaced by this simple construct, it's no point to create something different and complicate the language. Some extra benefit is that you can go further and make it multi-line per block. Just make sure that to keep it under control, because if you put 100 lines in this if block, it stops to be actually manageable, and the ternary operator sort of kept us at the safe place and safe number of lines. So it gives us the power, but it has to be used wisely. Actually, the same rule applies to different constructs like try-catch. So this approach of returning some value from some block, but you can check it out yourself. Accessors become properties. So it's the goal is to address this popular Java's place where we write a lot when we want to write not that lot. So here we have a simple class with two fields, and for each of them we have a getter and a setter. And how we use them, it looks like this. Simple. And in Kotlin, we have this. So what in Java would be like a simple field where you can just write and read. In Kotlin becomes a property. And also you can see on the right side, it looks like if I wanted to modify the field, right? It's like, I didn't like it at first because it looked like I didn't use an abstraction. I want to have these getters and setters in Java because maybe one day I want to add some validation. No, so fear not, there's a way to do it. So you can create sort of like functions for both of them. They are called get and set, where you have the direct access to the field. From my experience, I really rarely see this kind of code. Most of the cases, the getter and setter is just enough, because it's also pretty surprising when the getters and setters do something more. So we try to avoid this. But it's also good that Kotlin gives us this nice syntax for really common thing. No static keyword. Come on, I want to create some constant, but I don't know how. Why they remove the static keyword? Well, so yeah, we have actually 3 use cases for the static keyword. One of them is like a class level constant, or like this. The other one is static function. It means that it doesn't have access to the classes field. And also the third one is static class, which means that this inner class doesn't have access to the parents fields. Let's see how it can be written in Kotlin. So you see some new keyword here, companion object. Let me first explain quickly what it means. So in Kotlin, they tried to make everything an object. So instead of putting these static entities on the class level, they decided to make this sort of object inside an object, but it's shared between all the instances of the class. What this gives us, for example, you can implement some interface on in this object. It may be useful, but also, as I said, makes everything an object, which also makes some other stuff easier. So to address our few use cases, first one is the constants. You can either use the top level constant or the companion object. And the difference is that in the first case, you just don't use the any class's name when you access this, which may be what you want or may not be. In case of static functions, the same case. And in case of static classes, Kotlin differentiates on nested class and inner class. We just need an extra keyword inner in this case, as you see. And here we have some bonus feature, not really related to the language, but to the general ecosystem of Kotlin. So there's a built-in converter from Java to Kotlin. Let's see it again. Okay, we have a GIF in a loop. So you have some simple Java code. You just copy it to the clipboard, go to the Kotlin file, paste it, agree to convert. Yes, click it. Yeah, and now we got it. So this example is pretty spectacular. In some cases, the converter is not that brilliant, but I admit that it helps in the first days of using Kotlin, because you you sort of try to ask yourself questions. How do I write this stuff in Kotlin? So this converter doesn't produce that clean code, and it usually needs some cleanup, but it's a good start for the beginners. So that's all. Thank you. Let's see. Okay, the Slido, let's do it at the end, right? Okay, so now let me give the microphone to Greg.